Hello everyone and welcome back. Last week we did the Tic-Tac-Toe game, the basic version, and we were playing it in the terminal against like a player X and O. This week I want to do this project using AI, not in the large language model sense of AI, more like a couple of lines of code AI that will check for the best move and will make you never win the game in tic-tac-toe. I will use Minimax Algorithm AI for this project. I am using GitHub code spaces. It will be a C project, and I hope you like it. I am starting by creating tic-tac-toe AI.c file. It will be quite similar to the one we did last week, so I will even use some functions as the same. For example, this part we can just copy and paste. But in this case, I will be defining two more variables, which will be player X, and I will define AI as the O. You can change it if you want, but this should be this is how I will do it. I will also including std library, standard library.h, and of course we have a main function. No arguments necessary. We will have winner, and we will have winner as the same last one, which is empty for now. We will have the current player, which will be the player beginning. And of course, we will start by initializing the board. Actually, it will be the same function, so I can just copy and paste. It is basically initializing the board with empty spaces. We will have a grid 2 by 3, and it will initialize as empty. And after initializing the board, we want to display the board, so I will just copy and paste it again from the last week's version. This will be our beginning. Tic-Tac-Toe AI.c, or let's say test. If I run the test, now we have initialized the board to empty spaces, and we can display the board in our terminal. And these two are just copy of the last week. I don't want to spend time explaining them again because they're quite simple. We have a nested for loop that initializing the board, and we have another nested for loop that's printing the nice stuff, like the visual stuff that we like, the columns, the rows. So same as this one. Will be mostly similar to our last version, but this time we will not be playing against ourselves rather than AI. So of course we will need to make some modifications. After displaying the board, last time we first checked if we have a winner. If we don't have a winner, we are checking if the board is full, and we are switching players, which was working nice. This time I will make some changes. For example, first I will check who the player is. If the player is us, if the current player is the player, which is us, we will have a function called player move, which will take the player. Same with this one. It will be this function will handle the player move. As the name suggests, it's a void function. And actually it is the same one as the last week, so I'm just gonna copy and paste. It prints a message to the terminal asking to player to enter row and a column. It's checking if the move is legit. Is it in the 1 to 3 range for the row and column, and as long as it's also empty, so there's not a previous move that made in that cell, we will process the move. And if it's not okay, we will just say invalid move and try again and wait for wait in the while loop for the player to give us the correct move. And if the current player is our player, we are making the move, and else means current player is not the player but the AI. We will say we will check for the best possibilities. So we will have two integers. We will call them best row and best column. For the AI, we have another function called find best move, which will take the address for the best row and also the best column. And it will display, it will change the best row and best column to the AI. So in this case, AI is O. That's what I meant. We have a function to find the best move. It will check which is the best place to put the O in the best row and best column, same as we are checking and in changing the value of the empty to the players. This time we are checking the best place and changing it, changing the char that includes to the AI. And of course now we need to make the find the best move function. Now we will make a void function to find the best move, which will have two arguments, the function, and in the main function we give it address of the best row and address of the best column. So in this function we will receive, we will be asking pointers that points to that address, and it will be int pointer best row and another int pointer best column. And this function will be the find best move for the AI. I have a variable called int best value. I will just call it val, which will have the int minimum. Int minimum is in the header of the limits.h. I think I added this header without recording. And I don't think we need any more part of this old version. We already copied a couple functions because I'm lazy and they work fine in this project too. And in this find the best move function, we have a value, and so we will have a for loop. It's a simple for loop is less than size plus plus. I believe that's it. And this for loop, we will have another for loop. It's a nested for loop. J is less than size. J plus plus. First, we will check for the empty places in the board. So I will say board I of j equals empty. So first, we are checking the empty cells in the board. Then we will say board I of j is AI. And we will have an int move value, which will be our AI function. I will call it minimax 0 and 0. It will be an algorithm to find the best move. And we don't have it yet. We will have it in a second. And then we will go back and make it to empty cell again. So I want to finish this function before starting the minimax. And basically, when we find the empty cell and we are making it temporarily the AI char, which is O, and we are checking if the minimax move value makes sense, and then of course setting it back to empty space because we don't want to change the move. After we have the move value, we are checking if the move value is larger than the best value. Basically, we are checking if the move makes sense. If that's the case, it means we found the best move, and its best row will be the I, and the best column pointer will be the J. And best value will be the move value that we just created here. And because of these are pointers to the integers, we don't need to return anything. It can stay as a void function. And now time to create the most important part of this project, Minimax AI. Let's take a minute talking about what Minimax is. I wrote a short summary. I want to say it talk about it quickly, how it will work. It is a simple decision-making algorithm that's used in two-player games like Tic-Tac-Toe in our case. It helps the AI to choose the best move by simulating all possible future games. It's not a very effective solution for big projects, but like I said before, in this kind of simple two-player games, it works fine. It is basically using recursion and backtracking. And basically, the algorithm explores every possible move by recursively. It checks if it wins or loses or it's a draw. And then we will evaluate. We will have an evaluate function that will check in each state of the game, will assign a score in each state of the game. It will be plus 10 if the AI wins, minus 10 if the player wins, and it will give 0 for the draw. And it will minimize and maximize. The AI will be maximized. It will pick the move with the highest score. And it will also check the player's minimized score, which will be the lowest score for the player. And there will be some optional move selection. It will evaluate all possible moves and chooses the one that guarantees the best possible outcome, making it unbeatable. And the key idea, Minimax will simulate all possible future game, and it will score all the possible outcomes, and it will choose the less convenient for the player. So basically, we are making an impossible to win Minimax AI. To create the Minimax AI, we will need something that similar that we use in the first version, the simple version, that we were checking the winner. And if you remember, in this case, we have a for loop that checks if we have a win situation in the rows of the board or columns or diagonally. And we will have something similar again, but this time I will call it evaluate, which is the name will make sense because it will evaluate the board to determine the state. In the check winner, we were checking if we have a winner, but this time we will check what will happen. And it will be an integer function. I will evaluate. There's no arguments it's taking. It will be same as this one. I can just copy it actually and change a couple stuff. For example, we will check again if the rows are a match with each other, we are checking the I of the 0 and I of the 1 and I of 2. We are checking if the two of them are the same and also they are not empty. In that case, we were returning the board, which character is there, like if it's X or O. This time we will check. We can have a lambda function, or I can just write it. This time we will check if the board I0 is AI. If it is AI, we will return 10. Else, we will return -10. Instead of this one, we will be checking if it's AI, we will return +10. If it is not AI, we will return -10. So that's what our AI will be checking for. Or another way to write this, like this one, I can use a lambda, which will return board 0 of I. It will check if it is AI char. Question mark means if. If it's that's 2, it will return 10. Else it will return -10. I like this one to be open, but I am going to use this for the next ones because it's more convenient for me. And same with this one. We are checking if board 0 of 0 is AI. In that case, we are returning 10, else -10. And same with the last one. We are checking if board 02 is equal to AI. If that's the case, we return 10. Else we return -10. And if there's no winner, we will return 0. This is a little bit different from the first version, but still, same idea. And now we can start having our Minimax Algorithm to find the best move. Like I said before, our goal is to make a unbeatable AI. So for that, I will create the function. It will have two arguments, int depth and int is max, which we gave 0 when we called in the find the best move function. We will have a variable called score, and it will come from evaluating the situation of the board. This function is checking the board, evaluates, and it turns -10, 10, or 0, depending on the evaluation. And if we have score of 10, score is 10, or score is -10, it means we have a winner. And in that case, we just want to return the score to our main file. And we want, when we return in the main file, we will be checking the winner, and of course we will evaluate, and we will check if our winner is 10 or winner is -10. Like we are checking if the AI or the player wins the game. We will again display the board, and we will type player %C wins, new line. And it will check who is the winner. And for that, I will have another lambda function. It will check if the winner is 10. If the winner is 10, now we know what that means. It means the AI is the winner, or it will be the player if it is if it is 10, it is AI. If it is not 10, it means -10. It will be the player. You can also say current player, but at some point I'm afraid we can change the current player accidentally, so I will just leave it like this. This is a safer version. And if you have a winner, of course you want to break out of the while loop. And if you continue to Minimax, we are checking if we have a winner, and if not, we want to check if AI can make moves. That's the important part. And in the first one, we had a function called is board full. We now have another one which is similar in the idea. Actually, it's even the same, only difference. I will call it is moves left, and it will check if any moves are left. I mean, it will check if the board is full, basically. And I will call it is moves left, which will not have any arguments. It will look the same as is board full at the idea, but this time, if there's places, it will return 1, and it will return 0 in case of board is full. But we will say mm, moves left and no moves left. I made a typo. Let's fix that. And now I'm going back to main. We can check uh, for if we have moves left now. Is moves left, which will return 0. If there's no moves left, it will display board and it will print and say it's a tie line, and it will again break out of the loop. Also, same in the Minimax, we need to check if there's moves left, and if it is 1, it will return 0. Oops. If there's no moves left, and I'm saying not no moves, meaning minus minus makes a positive 1. If there's no moves left, it will return 0. And if the move value returns 0, it means no moves left, so it will just run out of the loop and it will terminate the game saying it's a tie. To continue the Minimax, I am checking if I am missing anything. I don't think so, and this is the last part, then we will finish this project. I will have a variable called best, which will be checking is max. That's 2. It will check, it will return int minimum. If not, it will return int max, meaning is the best score is the maximum, which is the maximum will be 0. It will check is maximum is minimum, else maximum. So just wait for a minute. We will have a nested loop again. Same with others. Plus J 0 J plus plus. In this loop, we will check for is the board empty? Board is empty. We will check board J equals is that there. Is max will be 0. It will check if the place it will check if it is 0. It will turn AI or player. Like, it is difficult to explain, but if you can visualize in your mind, we will place a possible move, checking if it's players moves or AI moves, and we will calculate a value, and we will say, okay, this is the best value or this is not a good value, and we will move forward that. I said we will have a value integer which will be minimax depth plus 1 and not opposite of whatever we had it for. So we will have a recursion function that will call it itself until it finds the best value, and it will continue searching for what is the best, and it will check if the best is larger than the value. If the value is larger than the best, we will return the value, else we will just continue with the best. And if that's not the case, this is the else part, we will check if the value is less than the best. If so, we will return the value, or we will return the best. And after we are doing this, we need to clean what we did. We will again make the char at that point empty, and we will return the best. I don't know if I explained this well, but we basically made a recursive function that checks itself, trying to find the best value, giving it scores for 10 and -10, and it returns when it finds the best value. This was all, and of course, same like the last time. After each move, we need to change the current player. We will check if the current player is the player. If that's the case, we will return AI, else we will return the player. If there's no problems, we will return 0 in the main function. Let's see if everything works. I will 1 1. Okay. I placed my X in 1 1. The AI placed in the other part. I say 1 2. AI blocked my way of having a 3 axis. I say 2 1, and player O wins. AI beat me. Again, I say 3 3. I say 3 3. Block. Oops. I'm still stay 1. Go 1 1, and player O wins again. I will try again. I will say let's go to middle. 2 1 2 3, and AI wins again. Basically, we made a Minimax AI enemy tic-tac-toe game. The Minimax algorithm ensures an unbeatable AI. It evaluates all possible moves and chooses the best one. It recursively simulates the future game states, as we showed here. It gets deeper and deeper to the game until there's no more moves to make. It works because this is a simple language 3x3 9-cell game. There's not a lot of possibilities it needs to check. It is using recursion and backtracking. It guarantees optimal decision making for tic-tac-toe salt game. And this AI never loses, and it plays perfectly. And this can also be used in chess or other similar two-person games, two-player games. And I hope this video was helpful. I hope this gives you some ideas. Thank you for watching. I will post the code repository, my GitHub repository in the description. Thank you for watching. See you next time.